Homework. Here is your homework. So starting with question number 1. An online sales store started its business. 15 sales. If their sales increased by 18%, use an exponential growth model. That's what I'm looking for. So to start with, this is an exponential growth model. And because it's growing, you're adding. And then I just fill in the numbers that I need to. So it starts with 15 sales. It's increasing at 18%. So that's 0.18. And then it says use it to find the week in which they exceeded 1,000 sales. So there it is, right there. So we're filling in. These questions we're either going to be solving for time or for a rate. So I need to have the ability, the algebra ability, to simplify this and solve for t. So divide by 15. I'm just going to leave it that way. So 1,000 divided by 15. 1 plus 0.18 is just 1.18. And then I need to write this exponentially. So the exponent is t. The logarithm has a base of 1.18. And then inside the logarithm is 1,000 divided by 15. And then we'll write a simple sentence. All right, so let's go to the calculator together. And then we'll type it in. So to type this in, we're going to type in log, and it's 1,000 divided by 15. Oops, I meant to get a parentheses in there. Let's try it again. Log, parentheses, 1,000 divided by 15. Move the cursor, and then that is divided by log 1.18. There it is. That's how you type in a logarithm. Oh, how did I get capitals in there? Oops. Let's try it again. So log 1.18. Beautiful. So that's 25.374. So then the question is, use it to find the week in which that's seated. So during week of 26, if you round, so during week 26. So during week 26, sales exceeded 1,000 per week. All right. A certain chemical has a half-life. So that already tells me the bottle I'm going to use. Half-life. So that's subtract. And it's every 3 days. So that's T divided by 3. So there's the model. We're starting with 750 ounces. 1 take away 0.5 is 0.5. And we want to know when we have 100 left. And so how many days have passed. So there's the model. Now we're going to solve it. So to solve it, we're going to divide by 750. I'm just going to leave the number exactly the way it looks. To solve this, we're going to write it as a logarithm. So the exponent is t divided by 3. The logarithm has a base of 0.5, and inside the logarithm is 100 divided by 750. To get t by itself, you multiply by 3. And now we're going to use our calculator. So to type this in the calculator, we're going to type in log. So it's log 100. So we're going to use parentheses. So it's 100 divided by 750. Move the cursor. Divided by log, parentheses, 0.5. Move the cursor. Divided by, no, not divided, times. So now it's times 3. Done. So you get the answer 8.72. So how many days have passed? Almost 9. So almost 9 days have passed when 100 ounces remain. All right, number 3. The average price of gas in 2006 was $3.92. In 2017, it went down to $2.36 using a continuous exponential decay model. So that's still this continuous. What decay just means the rate is going to be negative. It's going to be P times E to the RT. Our initial amount was $3.92. The end amount was $2.36. I'm looking for the rate. The amount of time from 2006 to 2017 was 11 years. So now I'm looking for the rate. So solve for R. So step 1 is to divide by 3.92. I'm not going to reduce it down. E to the 11R. Write this as a logarithm. So the exponent is 11R. The logarithm that has a base of E is ln, silly. And then what goes inside that is 2.36 divided by 392. The last step is to divide by 11 and then use your calculator. So let's type that in and divide it by 11. So that's ln. Inside the ln would be 2.36 divided by 392. Then we're going to divide that by 11. So that is negative 0.046. Oops. Let's come back here. There it is. So negative 0.046. So it's a rate, so we're going to move the decimal to the right. So the question is the decay rate. So the decay rate over 11 years is, and it's and as you say the word decay, you don't have to put down negative. So move the decimal. And so it was decaying at this rate. The word decay means the number is negative, so we don't need another negative. If you're decaying at a negative number, it's a negative with another negative. It's actually increasing. All right. So because we say the word decay, we can just write down 4.6%. 4. A flu pandemic. Jeez Louise. Has hit a local daycare. So the population of sick children is represented in this equation, where P is the number of sick children and T is the number of days since the first child was diagnosed. So those that are fighting a pandemic, it is math and science to understand this logistic growth model so we can flatten out and be able to then decrease the number that have been infected. All right. So here's our growth model we're using. How many days will it take for 50 children to catch the flu? That's what P is. So we're going to make it equal to 50, and then we're going to solve this equation. So we're going to multiply both sides by the denominator, 1 plus 7 times e to the negative 22t. Next, to get t by itself, we're going to divide by 50. Next, we're going to subtract 1. So 110 divided by 50, subtract 1. Next, we're going to divide that by 7. Notice I'm not even bothering to simplify it. So 110 divided by 50, subtract 1, divide by 7. Write this as a logarithm. So that's negative 0.22t. That's 110 over 50. Subtract 1. Oops. That's the ln of that, sorry. So what logarithm has a base of e? It's ln. And then put that in, 110 divided by 50, subtract 1 divided by 7. And then the last step is to divide by negative 0.22. So see if we have that skill to type that into a calculator. So We're going to go ln parentheses 110. In fact, I'm going to start with another parentheses, another divide sign, and then in the numerator, I'm going to go 110 divided by 50. Move the cursor, subtract 1. In the denominator of the logarithm is 7. And then take that answer divided by a negative 0.22. So all that work. So how many days? And the answer is about 8. So it will take about 8 days for 50 children to catch the flu. All right, turn the page. We're halfway done our homework. The weight of a Doberman puppy, that's awfully cute, can be modeled by the equation below where W is the weight of the puppy and T is the number of weeks since the puppy was born. How many weeks will it take the Doberman to reach a weight of 75 pounds? So the weight is 75 pounds. Can you do the algebra to get T by itself here? So step 1 is to multiply both sides by that denominator. So it's 23e and it's negative 0.15t equals 95. The next step, and this is how much the Doberman will weigh at the end. So at its height of the weight, it'll be 95 pounds. All right, divide by 75. Subtract 1. Then I'm going to divide by 23. And then I write it as a logarithm. Now, to write this as a logarithm, the exponent is negative 0.15t. The logarithm that has a base of e is ln. And then all of this will go inside the logarithm. So 95 over 75, subtract 1, all divided by 23. The last step to get t by itself is to divide that number by negative 0.15. And now use your calculator. So how many, is that in weeks? Yep, weeks. That's it, 20, like 30 weeks if I round up. So it'd take about 30 weeks and suddenly it's 75 pounds. Unbelievable. So it started at 23 pounds, right? I don't know what it started at. But yeah, I'm telling you, it would take 30 weeks to get to 75 pounds. And then it's no longer a puppy, right? At 30 weeks. Number 6, a deposit of $1,000 is made to an account that accrues interest compounded continuously. So there's my model. So the model is this is the model to compound continuously. After 14 years, the account has a balance of that. If there are no additional deposits, find the interest rate. So the initial amount was $1,000. Then after 14 years, there's $2,857.65. And now I'm solving for the rate. Step 1 is to divide by 1,000. Now I'm going to tell you, when you divide by 1,000, you're just moving the decimal back 3 places. So that'd be 2.85765. So just move the decimal back 3 spaces. So 1, 23. There it is. Next, we're going to write this as a logarithm. So the exponent is 14r. The logarithm that has a base of e is ln, and then what goes inside is 2.85765. Do not truncate it. The whole number. Divide it by 14, and then use your calculator. So it's ln 2.85765. Move the cursor, divided by 14. So there's the interest rate. So I'm going to write down 0.075. Rounded. So the question is, find the interest rate. So the interest rate over 14 years was 7.5%. What a great return in investment. All right, number 7, 2 more left. A retirement account was opened, $900. It earns 4.25%, compounded continuously. So that gives me the model. And then how long will it take for the value to double? So we're starting with 900. If I double 900, it's 1800. And that is, the interest rate I know. So the interest rate is 0.0425. What I don't know is the time. So there's my setup. Now I'm going to solve for t. So divide by 900. That's 2. That's doubling. Next, write this as a logarithm. So the exponent is 0.0425t. The logarithm is ln, and inside is 2. Divide by 0.0425. And now use your calculator. So ln 2 divided by 0.0425. And that is 16. So the question was, how long will it take? It will take about 16 years to reach $1,800, or to double your money. Okay, last one. Sarah opened a savings account, $725. The account earns 3.5%, compounded twice each month. So that gives me the model. So if it's compounding twice each month, this is what the model looks like. So it's P parentheses 1 plus the interest rate. Now, twice each month per year, 12 months times 2, that'd be 24 times a year. So that's what the model looks like if it's twice each month. And so we started with 725. How long will it take it to reach 2,000? So that's the end amount. The interest rate is 3.5%. So as a decimal, that's 0.035. And then I'm solving for t. So there's the setup. Now do you have the algebra skills to solve for t? So divide by 725. So we have 2,000 divided by 725. We have 1 plus 0.035. This might be helpful to type in a calculator. So let me do that. So I'm going to type in 1 plus 0.035 divided by 24. Oops. Oh, it's an ugly number. So 0.03. So I'm not going to use it. I'm going to use the complete number then. The next step, we're going to write this as a logarithm. So the exponent is 24t. The logarithm is going to have an ugly base to it. 1 plus 0.035 divided by 24. But you can do it. And then inside the logarithm is 2,000 divided by 725. So this is really going to test your ability to put in the calculator. So divide by 24. Be patient with yourself. Can you type that in a calculator or not? Here we go. Let's see if I can. So we're going to start with a divide sign. I'm going to type in log, and it starts with 2,000 over 725. Divided by a log, and inside that log will be 1 plus 0.035 divided by, or just divided by 24. Move the cursor, and then divide that by 24. Wow, that took some patience. Can you get to 29 with me? So how long would it take? That's the question. If it's compounded, and the answer is it would take 29 years, about. There it is. You did your homework. I'm super proud of you. Mr. G Math over and out.